Hey guys, so we're on page 17 and we're talking about cofunctions, and before we talk about cofunctions and before I tell you what that means, we are going to look into some identities that you know. I never refer to them as these identities, but you actually do know these. In the future, when we talk more about trig, I'm going to give you some more identities that you will have to know, and those will be new to you. But these so far are pretty basic because the first set, they're called reciprocal identities, and you know the reciprocals. You know that sine and cosecant are reciprocals. You know that cos and secant are reciprocals, and you know that tangent and cotangent are reciprocals. So if I take that further and if I actually write that down as a reciprocal, I'm going to say that cosecant of theta, since it's the reciprocal of sine, I'm going to write that as 1 over sine to show exactly that. Similarly, for secant of theta, I'm going to write down that it's the reciprocal of cos by saying 1 over cos of theta. And for tangent, I'm going to write that down as, cotangent, I'm going to write that down as 1 over tangent of theta. The other set of identities that you do know, again, we'd never called it this, but quotient identities, and that refers to tangent of theta and cotangent of theta. The reason why we call these quotient identities is because in order to find them, you do have to divide and work with fractions and things like that. So as you remember, tangent is y over x. In other words, to find tangent, you do have to take your sine value and divide it by your cos. For cotangent then, because we know these are reciprocals, cotangent will then be cos of any angle over sine of that same angle. So keeping those in mind, what we're going to do now is we're going to prove some statements and we're going to evaluate some others. Now I don't want you to be intimidated when I say prove, because I know a lot of you tend to get intimidated, but basically we are, if you take a look at numbers 1 and 2, we're simply going to rewrite the left side so that it turns into what the right side tells me. That's all I'm doing. So if I take a look at number 1, I have secant and cotangent on the left side being multiplied to give me cosecant. Now to prove that, what I'm going to do is on the left side I'm going to rewrite everything that's there in terms of sine and cos, because that's putting it in simplest terms. So now secant, I know, as we stated just up here, I know secant is 1 over cos, so let me write that down. And I know cotangent, in terms of sine and cos, is actually cos over sine. Now we want to show that that equals cosecant of theta. So let me see what happens here. When you multiply fractions, remember you can always simplify diagonally, and if I do that, your coses go away. And so what I'm left with, it's kind of nice the way it works out, all I'm left with is 1 over sine of theta, which does equal cosecant of theta because they're reciprocals. So I'm going to show that exactly this way. Cosecant of theta equals cosecant of theta, and we're done. There's your proof. Number 2, let's do the same thing. We're going to rewrite the left side all in terms of sine and cosine. Well, sine of theta is just sine of theta. Can't do anything there. But secant I can write as 1 over cos. So let me go ahead and do that. 1 over cos of theta. And I want to show that those multiplied give me tan of theta. So what I'm going to do is I'm going to write sine of theta as a fraction, so sine over 1. And I can't cancel anything, but I can go ahead and multiply straight across my numerator times numerator, denominator and denominator, and that will give me sine of theta over cos of theta. And as you know, according to our quotient, sine over cos is tangent. So I'm going to say tangent of theta is tangent of theta. There you go. Number 3, you're going to do the same thing. So again, try to write the left side, and actually there is only the left side, but go ahead and write down all the trig functions in terms of sine and cosine. And you'll notice here that instead of an angle, instead of theta, you're actually given a radian. So we're going to actually evaluate this. We're going to actually give it a number, an answer. But before we do that, let's simplify whatever we can. So sine of pi over 6 is simply sine of pi over 6. I'll leave that as is. Cotangent of pi over 6, I can rewrite as cos of pi over 6 over sine of pi over 6. And I need to figure out what that gives me. Now here's what happens. Just like we did on number 2, I'm going to go ahead and put sine of pi over 6 over 1. That way I can multiply the fractions, and if you take a look at it, I can actually go ahead and cross out sine of pi over 6 because they're the same. So now all I'm left with is cos of pi over 6, and we can evaluate that. Basically what that's asking for is at pi over 6, at the angle pi over 6, which is 30 degrees, what's your cos value? What's your x value? And you would just say root 3 over 2. There you go. Number 4, again, notice that you are given angles, very specific angles, and the only thing on this one is that I can't really rewrite cos in any other simplified way. It's already simplified as is. Now all I have to do is find those values and simplify. So at 60 degrees, if I take a look at my unit circle, here's 60 degrees right here. What's the point? What's a coordinate at 60 degrees? Yeah, you should be looking at a half comma root 3 over 2. So if that's the case, my cos value at 60 degrees is a half. It's your x value. And then for 30 degrees, that will be right here. What's your coordinate for 30 degrees? Yep, it's flipped. So root 3 over 2, comma, a half. And so our x value here at cos of 30, or at 30 degrees, is root 3 over 2. Now all I have to do is simplify those two. And so I'm going to keep the first fraction, multiply by the reciprocal of the bottom, and the 2's cancel, leaving me with 1 over root 3. And I do have to rationalize, and once I do, I end up getting square root of 3 over 3. That's your answer. Okay, on page 18, it's a different idea. Now this is where cofunctions actually come in. So let's take a look at what we have here. So you're given all of these identities. The first thing I want you to do is go ahead and box that or highlight that. That way you have those right there for you. We're going to come back to these, but let me define, or let me give you an example of a cofunction before I move on. So if I ask you for cos of 0 radians. In other words, at 0 radians, what's your x value? So if I take a look at my unit circle, I know my location, my point over there is at 1, 0. My cos value then is simply 1. Now what if I also ask you what's the sine of pi over 2? So at pi over 2, what's your sine value? That's also 1. So what we're going to say is that cos of 0 and sine of pi over 2 are cofunctions because they have the same value. Let me write that down. Cos of 0 and sine at pi over 2 are cofunctions because they have the same value. Now the other thing I want you to notice is that if we were to take the point that's at 0 or 0 radians, and if I were to rotate that point, or if I were to go from 0 radians to pi over 2 radians, that rotation of pi over 2 gives me a cofunction, which is the reason why you see all of these pi over 2's in your identities that are right below. But the basic idea is that whenever you have two angles that are pi over 2 apart and have the same value, they are called cofunctions. So let's take a look at some more examples, and then that way you'll actually understand how these identities work. So if I take a look at number 1, which by the way does have a typo, that half should really say root 3 over 2. So go ahead and make that correction. And you can actually verify that because that is on the unit circle at 30 degrees, right over here. I know my point is root 3 over 2, comma, a half. That's at 30 degrees. So this is the information that's given to you. It's a true statement after we changed that typo. And it's asking for you to solve or evaluate all of these parts. Now, some of them will be easier than others. Parts C and D are a little bit different. These are actually cofunctions, so we'll come back to that. But let's go ahead and do B first. And the reason why I'm doing that first is because it's asking for secant. And as you know, secant and cosine are reciprocals. So all I have to do is flip or take the reciprocal of that value, which will be 2 over root 3, rationalize it, so 2 root 3 over 3, and that will be your answer. That's the secant value at 30 degrees. Now let's go back to find tangent. How do you find tangent again? So you should find sine of 30 degrees over cos of 30 degrees to be able to find your tangent. So now I know cos of 30 degrees is root 3 over 2. And if I take a look at my coordinate, I know sine, my y value, is a half. Now all I have to do is keep the first fraction multiplied by the reciprocal of the bottom so that the 2's cancel and leave you with 1 over root 3. And after we rationalize, it ends up giving you root 3 over 3. And there's the tangent of 30 degrees. Now part C is asking for you to find sine of 90 degrees minus 30 degrees. And some of y'all may look at that and say, oh, well, that's just asking for sine of 60 degrees. Now I want you to hang on to that thought because I'm going to come back to that. But let me actually refer this back to the identities that are up here. And the reason why this goes with identity, more specifically that first identity that's up here, is because notice that it's in the same format. 90 degrees is pi over 2. And in the identity, it has minus u. Just make a note to yourself that u, in this case, is going to refer to some angle, which normally we call theta, but it doesn't really matter what we call the angle as long as we know it's some angle. Okay, but in this case, u will be some angle. We'll call it theta if you want. Now, in this case, our angle, our u, or our theta, is 30 degrees. Okay, so now it is in the same format. Really, because this is a cofunction identity, this is really just asking you to find cosine of that angle that you're working with. So if I follow my identity, this is really asking for cos of my angle, which is 30 degrees. Now, of course, you do have to evaluate that. So what was cos of 30 degrees? Yeah, it's root 3 over 2. There you go, done. So the cofunction is root 3 over 2. Now here's where your first thought comes back. Sine of 60 degrees, if you were to look at it that way, let's say you read that and you didn't even realize that it's a cofunction. If you looked at it this way, sine of 60 degrees, what is sine of 60 degrees? So if you draw out your unit circle, if you remember the coordinates, sine of 60 degrees is actually root 3 over 2. What do you notice about these two answers? Yep, they are the same. And again, based on our explanation, based on our definition up here, I can say for this example that cos of 30 degrees and sine of 60 degrees are cofunctions because they have the same value. Okay. Part D, again, it's asking for another cofunction. So now I'm looking at cos of 90 minus my angle. So cos of 90 minus my angle is really asking for sine of your angle, which is in this case 30 degrees. Now sine of 30 degrees, according to my coordinate, is a half. So there's that. And again, let's just say that you did not see this as a cofunction, and you just said, okay, well, that's cos of 60 degrees. Now, what's cos of 60 degrees then? Yeah, that's also a half. Again, these are cofunctions, and that's what will happen with cofunctions. They'll end up giving you the same answer, the same value. Okay, now number 2, you have given to you tan of beta is root 3. Now for this one, it's going to be a little bit tricky. Let's actually, before we get into all the details, let's go ahead and do whatever we can very simply. And if you take a look, notice that cotangent is a reciprocal of tangent, so that one's really easy. All I have to do is take the reciprocal of this number, which would be 1 over root 3. And of course, I do have to rationalize, so root 3 over 3. So there's that, done. Now part B and part C is asking about sine, and I know this is a cofunction, but part B, I do need to find sine. So what I'm going to do is I'm going to have to figure out, using only what's given, what will sine be. So let's think about it this way. I know that to find tan of any angle, I have to use sine of that angle over cos of that angle. And typically sine and cos are fractions, and of course I have to do all that fraction work to simplify and end up with some very simple answer. And that very simple answer for this example is root 3. I know this is what I want to end up with. Now I don't know the in-between. I don't know sine, I don't know cos. I'm going to have to work backward to figure out what sine and cos are. So now I'm going to have to think about, because I know square root of 3 is on the unit circle, I remember that number, so I know that this is going to be on the unit circle at some point. So if you think about it, what's the only fraction on the unit circle that has square root of 3? Yeah, it's square root of 3 over 2. Now, how are you going to have to multiply? So is it going to be the numerator, which you keep the same, or is it going to be the denominator, which you have to take the reciprocal of? Take a look at where it is. So the fraction with the square root of 3, so square root of 3 over 2, is actually going to be at the top, and you kind of have to think backwards on this one. So it's going to have to be at the top, and so the only other fraction that ever comes with square root of 3 over 2 in the unit circle is a half, so that forces cos to be a half, because once you flip it, once you take the reciprocal to be able to simplify this, it turns into 2 over 1, and at that point, the 2's do cancel for you, and it leaves you with square root of 3. So really this, because it turned out just the way I wanted, what I need to focus on is this part right here, because that tells me what I need. So that tells me that for this example, for tan to be root 3, sine is root 3 over 2, so there's my answer. Sine is root 3 over 2, and cos is a half. Okay, so there's that answer is done. Part C is asking for a cofunction, so if I take a look at my identities, I know that this goes with the very first identity that's written at the top, and so really this is just asking me for cos of beta, which we just found to be a half. Okay, number 3. There's another typo for you. Sorry, you guys. This should be just the reciprocal, so it should be negative 2 over root 3. So you might have an idea now, this is also on the unit circle, and I can go ahead and fill in one of these because I know cosecant is a reciprocal, and it is a reciprocal of sine, so I'm going to fill that in. Your sine value will simply be negative root 3 over 2. So there's that. And now I have to figure out, okay, well if sine is negative root 3 over 2, then where is this angle? And you're probably thinking, well yeah, you have two options, and yes you do, because where is sine negative root 3 over 2? Well, it's negative in the third and fourth quadrant. I know that for sure. So let's just kind of focus on the third and fourth quadrants. And where is sine root 3 over 2? For which family? It's the pi over 3 family. So for all the pi over 3's, sine is root 3 over 2. So now I know that this will be my angle. And for that angle, I already know that sine is negative root 3 over 2, which must mean that the x value has to be negative a half. So now I know the point, and so I know my cos value. My cos value is simply my x, which is negative a half. And if I know cos, then I know secant, because those are reciprocals. So secant will be negative 2. There's that, done and done. Now the last thing it's asking for me to do is find the cotangent, I'm sorry, the tangent, and if I take a look at the identity that's above, that is a cofunction, so I'm being asked really for cotangent of that angle based on my identity. So what is cotangent of the angle? And to be able to find cotangent, we do have to find, because this one's not so obvious, we do have to actually find it. So it's going to be cos of theta over sine of theta. And I know cos is -1/2. I know sine is -√3/2. And once you simplify, you'll end up with 1/√3. And it is positive because you have a negative divided by a negative. But I do have to rationalize, and after I rationalize, I should end up with √3/3. Oops, 3. So there's my cotangent. Okay. At the bottom, you have these right triangle problems, and I know they're blank triangles, but go ahead and fill them in. So for the first one, we will go ahead and put this down as a 45-degree angle. This is your right angle, of course. And I'm going to use the left side, the opposite side of 45. I'm going to call that 25. I'm going to give it the value 25. I'm going to leave x unknown, and I'm going to leave r as an unknown. Now what this is going to do is you can actually use your knowledge based on what I've given. You can probably infer some things, but what I want you to do is actually show me, based on trig values, how to find r and how to find x using what you know. So what we're going to do is two things actually. To find x, what we're going to do to find x is, first of all, notice that x is the adjacent side to this 45-degree angle. So this is the adjacent side. Now if I know that, what I'm going to do is I'm going to say, okay, knowing the angle from SOHCAHTOA, using SOHCAHTOA, which trig function, sine, cosine, or tangent, can I use to somehow incorporate the adjacent, because that's what I'm looking for, and the opposite, because that's what I know. I know the opposite side. So which of these three trig functions has adjacent and opposite both? Right, it's your tangent. So we're going to use tangent of 45 degrees, and tangent, according to SOHCAHTOA, is opposite over adjacent. Opposite is 25. Adjacent is x, which I don't know. So there's a setup to find x using a trig value. I know there's a simpler way, but I want you to use the trig function and the trig value itself. So now the only thing I need to find out is x. I do know tangent of 45 degrees. Remember, 45 degrees is on the unit circle. If you find tangent, it's going to be 1. Pause the video if you need to work that out for a second. So I'm going to set 1 equal to the right side, so 25 over x. I'm going to go ahead and put this 1 over 1 so that this turns into a proportion, and so that I can cross multiply just like that, and I will find that x is 25. And hopefully that makes sense to you, because knowing that this is a 45-degree angle and knowing that this is a 90, that means this has to be a 45. And if this is a 45, 45, 90 triangle, then we know that these two sides have to be the same. And that's what we just found. Okay, now let's do something similar to find r. Again, we can always use the Pythagorean theorem. However, I want you to see this in terms of the angle, according to the angle. So now I want to use what I know to find what I don't know. So I want to use opposite and hypotenuse. Or you could do adjacent now that we know it, or you can use adjacent and hypotenuse. So which one of these can you use? Yeah, you can either use sine, because sine incorporates opposite and hypotenuse, or you can use cosine, which is adjacent over hypotenuse. You choose. I'm going to choose to use sine of 45 degrees, because sine of 45 degrees will be opposite over hypotenuse, which is r. Now my only unknown is r, and that's exactly what I need. So let me evaluate sine at 45 degrees. So at 45 degrees, what's your sine? What's your y value? It's root 2 over 2. Now all I have to do, again, set it equal to the right side and cross multiply to give you 50 equals square root of 2 times r. Now solve for r, so I'm going to divide by square root of 2, divide by square root of 2, and that gives me r equals 50 over square root of 2, and after I rationalize, I will find it to be 25 root 2. So there's that. To get some more practice, try number 2 yourself. If I call this angle right here 60 degrees,